Hello viewers, hope you all are having a great day. This is Soham from SNS Learning, wishing you a fruitful learning ahead. As you can see in the screen, in today's tutorial, we are going to learn about merge sort. One of the most common and vastly adopted sorting algorithm. This algorithm follows a divide and conquer approach to implement its sorting. So you will use Python to implement the merge sort algorithm. But before implementing directly in Python, let us have a look how merge sort actually works by this presentation. So as you can see in the screen, I have a list of 6 numbers which is stored in an array, and my target is to sort this array of 6 numbers into an ascending order. So now, as I have just said that it follows a divide and conquer approach, so let us have a quick idea about divide and conquer approach. What is this actually? So divide and conquer approach is basically follows the principle of dividing a problem into sub-problems. And this dividing sub-problem process would continue until we reach such a point where problem cannot be divided into subproblems further, which means that given a problem, you break it into subproblems until you reach to a point where that subproblem cannot be further broken into another subproblem. So you have a unit of problems which is indivisible. Now apply your fixes or apply your technique on that small portion of subproblem, merge them together and do it until you get to the final one. So it is breaking up the complex problem into smaller chunk of subproblems. Then after applying the fixes or applying the techniques on those smaller subproblems, you will again merge all those subproblems to have your actual solution in the actual input. So now merge sort follows a similar way. Now we have 6 different numbers stored in this array. So what we will do is we will divide this array into sub arrays. Let us select a midpoint of this array. As this is a array which stores 6 numbers, so let us assume that the midpoint is between 43 and 72. So from this point we will subdivide this array into 2 arrays of 3 numbers each. So how we would achieve that? This is the pictorial diagram. Now if you can see, we have just created 2 different arrays of 3 elements from the parent array. Now if you see the newly created array, this array can be further subdivided into 2 arrays. So let us do it. So this is the one. We have again subdivided the generated array of 3 numbers into 2 more sub-arrays, one with only 1 element and another with 2 elements. Now look at this step very carefully. The array which contains only one number, which is 67 in the left hand side and 72 in the right hand side, cannot be further subdivided because it contains only one element and you cannot subdivide this. It has become a unit of only one number. But the right hand side still contains 2 elements in the array. So this can be further subdivided. So let us do that. Now all the generated sub-arrays has been subdivided into its smallest unit or the indivisible unit. till this point or from this point onwards, you cannot subdivide these single arrays. So we have completed our division strategy. Now we have to do the conquer, or we have to apply the conquer mechanism, which means that we have to fix, or we have to apply our technique in these subdivision of problem where the problem or the subproblem reaches its last or indivisible unit. Now what we will do is we will sort these elements where only one number is there in this array. So if you see the last step of this pictorial diagram, we have 54 and 43, and we have 80 and 10. So what we'll do is we'll now sort these two arrays. So 54 and 43 is there. So if I sort this, it becomes 43 and 54, and the right hand side become 10 and 80. So it looks like this. Okay. So in the same way, I will traverse upwards until I reach my parent array. So look at the steps that is going to be shown here very carefully. So now for the last step is sorted. Okay, so just come to this step, 54 and 43, 18 and 10. So this is also sorted. Okay, so I have forwarded my control to one level upwards. Now if you look at this level of this tree, I have 67 in my left hand side and 43 and 54 in my right hand side. Similarly, in this branch I have 72 in my left hand side and 10 and 80 in my right hand side. So now my elements to be sorted is 67 and 43, 54, which is already sorted, 72 and 10 and 80. This is the unit which is already sorted. So now sort this and merge this. So it looks like this. So now this after merging becomes 43, 54 and 67, a sorted list, and this after merging becomes 10, 72 and 80. We will apply the same technique in these two arrays. So similarly, similar technique I've applied here. So after merging this 43, 54, 67 and 10, 72 and 80, I am finally getting my final array or my parent array, which is now sorted. So if you understand this is a perfect example of divide and conquer. First, we divided our entire array till a point where my array contains only one number. Okay, so when I reach that point, it means that my division strategy has been completed. Now I'll have to conquer those. So conquer means merging one after another those single units until I'm reaching my target, which in this case is my parent array, which is shown here as a green colored array. So this is the technique of merge sorting. I think we are in a good position now to move to coding so that we will see the actual implementation and how it works. So let us get back to the console of Python. So I'll write the program and I explain step by step for each of the line that I'm going to write here, and then we will analyze the output and we'll discuss further. So let me give it a name as say merge sort. Merge sort. Okay, let me set the language first. Python. Yeah. So merge sort. Now my input parameter would be obviously an array. So let me name it as nList. Now I'm going to follow the recursion procedure here because the strategy that I've just shown here is basically a recursion process. So I have to dig till the end or till the point of an indivisible subproblem. So it's basically a recursion. I'm doing a recursive procedure. So I'll write a recursive function here. So I have to write first the base condition. So base condition would be if length of my given array is greater than 1. Why I have written this? Because which means that when I'll be in a position where I only have one element in my array, the size or length of that array becomes 1. So that would be my end point. So that's why I have written this, that length of n list should be greater than 1. If it is not greater than 1, if it is equals to 1, then I have to exit from that recursive procedure. So that is my intention of having this condition here. Okay, so once if it is greater than 1, then I have to calculate, or I have to divide the array into two sub arrays, and for that I have to have a midpoint from where I'll divide that array. So let me calculate the position of that division by having a variable whose name is mid. That would be nothing but total length of my array, which is len of n list divided by 2. Okay, I'm doing an integer division here, so that's why 2 slash. Now once I have my mid position, I can say my left array, say L array, the name can be L array, which is equals to n list from starting till mid, and R array, which is my right array, would be equals to n list from mid position to last. Okay, so I'm done. So I have calculated my L array, or left array and right array. Now I have to recursively call the merge sort so that I can divide each array into sub arrays till I reach a point where the array contains only one element. So let me have a comment line here. Do a recursion call. Okay, done. So now merge sort L array. This is for a division of the left array, and then again merge sort same way right array. Okay, merge sort R array, done. Okay, now I have to have some counters like n equals to 0. I'll explain you why I'm writing this counter here. Let's say I'm taking 3 counters I, j and k, and I'm initializing those counters or variables as 0. So I'll have the first counter, which is I, to traverse through the left array, and I'll have the j counter, which is to calculate or traversing to the right array, and I'm having k to traverse or to point my actual array, which is n list here, or my input array. Okay, now I have to write some conditions for calculation or the comparison. I'll explain why or how this condition is going to work. So like, okay, so while I is less than means this is the first iteration, len of L array, and j, which is for the right array, is less than len of r array. Okay, then if, now my comparison will start from here, L array of I, which is the pointer, is less than R array of j, then I will put the smallest number in my n list. So then n list of k is equals to left array I, and I'll move my pointer to one position ahead. So in this step, what I have done is, say I have reached my last state where I have two arrays with single or unit number. So now I is initialized to 0 and j is initialized to 0. Now 0 is less than length of L array. Means if you do a smart calculation now, length of L array is 1 for the last step. J is less than R array. This is also true because j is 0 and it is less than 1 because my array size is 1. If I am taking the scenario which is at the last step. So now I am checking if from the two arrays or from the two sub arrays, if my left array, value of my left array of position 0, because I is now 0, is lesser than the value of my right array, which where position is again 0, then I'll take the smallest one and store it in the n list. So that's why if you see n list of k, now k is initialized to 0, so this is the first element is equals to n list left array of I. And once done, if this condition satisfies, then I'll move my pointer for left array to the next one. So that's why I have written I is equals to I plus 1. Now the same thing, I have to write the same thing for comparison or for the opposite condition. Means it may possible that right the element in the right array is smaller than left array. In that case, I have to pick up the element from right array and needs to store in the n list array. So this condition needs to be there also. Else, this is the else part. If it is not satisfied, which means the opposite thing, then n list of k would be equals to right array R array of j. Okay. In the same way, I will make my pointer to point to the next element, j plus 1. Okay. Now, once all these things is done, means either the if part or the else part is satisfied, which means that I have some elements in my n list. So I have to, after population of values in n list array, I have to make the same thing in n list array, which is pointing to the next element. So that's why I have to do this. K is equals to k plus 1. So k is now pointing to the next element of n list, so that for the next comparison, whatever the outcome would be, it would be stored in the next as its next element. So if it is now 0, then for the next iteration or next comparison, whatever the outcome would be, it would store in n list in the position of 1. So the second position. So this is done. Now I have to make 2 more conditions. I'll show you why. Let me write it first, then you will understand why I'm writing this condition. Okay, now while I is less than length of left array, then enlist k is equals to array of I. Sorry. Same way, I'll increase this count by 1 and I'll increase the pointer for enlist to 1 also. Okay. Now the same thing needs to be done for the right array also, so that's why length of R array, then enlist of k is equals to R array of j. Once done, I have to increment the same. So for that, j is equals to j plus 1 and k is equals to k plus 1. Okay. So I'm almost done with my conditions. Now I have to make some decorations like printing the elements so that it would be easier for us to understand the flow. Okay, so let me have the print condition here, like print merging enlist. This is the number that would be returned after recursion. Okay, and from here let me have my enlist initialized here. So enlist is equals to say 16, 10, 90, 56, 78, 5, 1, 2, 3, 4, 5, 6. Okay, done. Now from here I'm calling the mod sub, passing the enlist. Okay, I'm done. Let me do another thing so that we would know the contents of L array and R array for each calling of the recursion. So let me print it here also. Print left array is L array. In the same way, I'll print the right array also. So right array is R array. Okay, so I think I'm done with the coding. Let me save it and run it first, then I'll explain each and every step. So save as, okay, merge sort, it's a Python file. Okay, save. Let me open the console. So let me run it. Mod.py. Nothing is printed here, so means something is fishy in my coding. Okay, let me have a look on it. So enlist, okay, merge sort, fine, spelling is fine, no problem in it. Okay, I have made a blunder here. This should be outside the definition. So it was previously the Python programming thought that these two statements are inside this definition, so that's why no action was taken by Python. Anyway, now let me save it and run it again. I think it has produced the correct output. Yes. Okay, so let me now go step by step. So the first output is left array is 16, 10, 90 and the right array is 56, 78 and 5. Okay, so let me minimize it so that I can compare it side by side. So our input was 16, 10, 90, 56, 78 and 5. So if you divide it from the middle, so my left array is 16, 10 and 90 and my right array is 56, 78 and 5, which is fine. Okay, the next, this left array would be subdivided. Okay, so if you see the next iteration, my left array is 16, my right array is 10 and 90, which is perfect. Now, as my left array has only one element in it, which means this condition is satisfied. Enlist is greater than 1. No, it is not. That's why the control come out from here and directly hit this print statement here. This is the print statement, merging enlist. So now my enlist is 16. So it printed the number 16. Okay. Now once done, the control again returned back to the line where it executed last. So if you see, right array was 10 and 90. So it can be further subdivided. So now it has divided with left array as 10 and right array as 90. Now again 10 and 90, these are becoming a unit or indivisible unit. So that's why by this condition, len of enlist is greater than 1, this does not satisfy. So that's why if you see here, the first one is merging 10, the second one is merging 90. So this is basically left and right array. If you see here, this is left and this is right. Okay, now we have come to the last step where we are not able to further divide 10 and 90. Okay, so now as a principle of recursion, this 10 and 90, so as a principle of recursion, now it will, now as it has stored all the values of enlist in a memory of stack, it would start retrieving in a reverse order as followed in a stack of values. So if you don't have an idea how recursion works or how in a recursive function or procedure how the value is stored in a memory stack, I'll provide the link after this tutorial. You can go and check that out. So after 10 and 90, if you see here, so it is showing that merging 10 comma 90, because before 10 and 90 was subdivided, the parent value of 10 and 90 was an array which contains 10 and 90, which is this one. Okay, now once done, if you see here, before 10 and 90, or where 10 and 90 was there as an array or as an right array, there left array, the value of left array was 16. So that's why it is saying that merging 10, 16 and 90 here. Let me open the slide here. So this is the last step, right? Say this is the last step for the example that I had shown earlier. So the last step was like 43 and 54. Once this is done or this is merged, it will roll up to the previous state, where as a right array I'll have this sorted list, and as a left array I'll have another unsorted one. In the same way, if you see here, 10 and 90 is now sorted, but 16 was there as a left array. So now 16 was added and merged and created these array of these three elements. Now 10, 16 and 90 is sorted. Now what was there previously before 16? Before 16, it was a right array which contained 56, 17 and 5. Now it would be further subdivided into two sub-arrays. If you see, 56 is the left array and right array is 78 and 5. In the same way, like this one, this division has happened until the last one. Now once done, it is again started rolling up. Now after this list is sorted, which is 5, 56 and 78, it would merge with 10, 16 and 90. Okay, after merging, I'll be having my final output. I know this is a bit tricky and bit confusing, so let me open this one. I'll show you the condition that I've written, how it worked. Okay, so once my recursion call exits, my control will come here, right? So my condition is if I is less than length of left array and j is less than length of right array. Okay, so this is my left array now, this is my right array now, for example. The length of both of these is 1. Okay, so it satisfies this condition. Okay, now the next condition is if L array of I is less than R array of j. Now I or j is equals to 0. Okay, and as I am having only one element in my array now, so I'll simply compare this 43 and 54. So 43 is less than 54. L array is less than 54. Okay, then what will happen? Then my enlist would be L array of I. Okay, and I'll increment I and k both by 1. So my enlist becomes 43 because 43 is less than 54, and I'll increment I to 0 plus 1 with 1 and k with k plus 1 as 1. So now if you see this while condition, now I becomes 1. So 1 less than 1. No, it is not. So this condition is not satisfied. It will come out of the loop and will come here. Now this condition is while I less than length of L array. No, it is not true because I is 1 and 1 is not less than 1. So it will come directly to j. J is now 0. 0 is less than length of R array 1, which is 1. Yes. So enlist k means enlist 1 will become right array of j. Okay. Why enlist 1? Because we have already incremented the value of k to 1 in the first loop. So now in the second position, j value will be there. So this value would be populated as my second value in my enlist. Now because of this, because of recursion, it will retrieve this value now, because in the stack of values in memory after this 43 and 54 there was this array, and now it is sorted because I have done this sorting in the root element. So this is become my right array, and this has become my left array. Again I will do the same thing. Okay, now this is I and this is j, both are 0. Okay, so if you see this condition, I less than means 0 is less than 1 and j, now length of R array is 2. both the conditions satisfied, and I'll check if left array of I is less than R array of J. So 67, whether 67 is less than 43, because this is 0. No, it is not. Okay, so if it is not, then my condition is, else condition would be satisfied. So n list of k is R array of J, means now k value is 0. So this value, this j value would be populated in my n list. So 43 would be there, and I'll increment the value of j to j plus 1. So now j points to this value. Again the same checking would happen. Okay, it will now check whether 67 is less than 54 or not. No, it is not. Again 54 will be there in my n list, and j would be plus 1. As j would be plus 1, so j becomes 0 plus 1 1 plus 1 2. Okay, and this elements also having j right array is also having two elements, so length of this right array is also 2. So 2 less than 2 do not satisfy, so it will come out of this loop, and it will go directly in this portion where I value is still 0 and 0 is less than 1. So it will simply put 67 here, because my k value is now 3, because every iteration k value was incremented to 1, was incremented by 1. Okay, so if you see, this is the one that we have got here. Okay, in the same way this right tree is also been sorted, so we have got this. So now our left array is this, right array is this, the same checking would be there, taking this as my left array, taking this as my right array, and this would be my final outcome. So this is it for merge sort. If you like this video, do hit a like and share and subscribe.